Action potential. An action potential is a way of cells communicating with other cells, specifically nerve cells. But before an action potential is fired, the cell membrane has to be at resting membrane potential, at a charge approximately negative 70 millivolts, with more of a positive charge on the outside and a negative charge on the inside. We call that polarized. When an action potential is fired, the sodium channels open up, allowing sodium to enter the cell. This makes the cell more positive on the inside and more negative on the outside, allowing the cell to become more depolarized, which sends the action potential along. When it's depolarized, the charge goes down from negative 70 to negative 55 millivolts. Then, potassium channels bring in potassium ions to return the cell to resting membrane potential. But to do that, the cell also needs to pump out sodium ions that are still inside the cell to bring it back to resting membrane potential and a charge of negative 70 millivolts. Lights, camera, action potential. There are two types of axon bodies: continuous and saltatory. Saltatory are myelinated, which means they have Schwann cells and nodes of Rowley on them. These myelinated cells go faster, allowing the action potential to move much more quickly than with continuous, which are unmyelinated, which do not go as fast. Cut.
In the right corner, we have saltatory and football with a violent sheath. In the left-hand corner, we have continuous, non-myelinated axon sheath.
This race is to prove who can fire the action potential faster. Racers, on your marks, get set.
Action potential!